scientists suggesting the Earth may be on the verge of another mass extinction, similar to the one that killed the dinosaurs. It happened 5 times in the past 540 million years, but this time around, experts say we may be able to stop it. Michio Kaku is a physics professor at City University of New York and author of the new book, Physics of the Future, that we're going to be looking forward to the new book, of course. All right, Dr. Kaku, getting right to it. So which species would be most at risk?
Well, so far, if you analyze the last few hundred years of life on the Earth, human activity apparently has wiped out 1.4% of all plant and animal species, and it is 100 to 1,000 times faster than normal because of human population, development, pollution, overharvesting. And if you take a look at a zoo, many of the zoo animals that our children love, we may find them going extinct. The tiger, for example, may go extinct. Many of the familiar zoo animals, bears, and realize that 18,000 species are at risk.
And what about climate control? What role does it play?
Yeah, climate change is also involved in this thing. Independent of where climate change comes from, we see that the seasons are changing. Summers are getting longer, winters are getting shorter on average. And we always say that the early bird catches the worm, but that assumes that the worm and the bird are synchronized. Many of these cycles, the natural cycles, are being thrown into disarray, meaning, for example, droughts in China going on right now, perhaps famine in certain areas. So we humans cannot be divorced from what's happening in the natural world.
We can't be divorced. Is there something we can do about it? I guess you said pollution is one thing we can do. But so what happens, doctor, if there is not this sort of scientific pruning? Would the Earth be overrun with all sorts of creatures?
Well, evolution says survival of the fittest, and so far we humans are among the fittest. But we are also at the top of the food chain, the top of the pyramid, and it wouldn't take much to dislodge us from being at the top of the food chain.
So who could outrank us at that top of the food chain? You need to know what animals I need to look out for.
Well, in science fiction, of course, the insects take over. But look at something very simple. We are dependent on just a few crops, wheat, rice, and just a few crops, and if a blight were to wipe out these crops, then a huge chunk of humanity would starve to death because we're so dependent on just a few plants and animals for our existence.
So should we expand our menu, so to speak, or is there something else that the Earth provides that we should be looking at?
We should be wary of overharvesting. For example, overharvesting the oceans. We have drag nets, which in principle could drag the entire oceans. That's how efficient our technology is. Also, wheat production we have to worry about because water is the key to wheat production, and there are going to be perhaps water wars in the future.
And are you concerned about that water wars and that we may run out of water?
Well, there will always be water on the Earth. The question is the cost and what it would take to extract it, to desalinate it, to divert it, to irrigate. And so the cost of certain kinds of commodities could start to rise. So just because we're at the top of the food chain doesn't mean that we're invulnerable to what's happening outside where biodiversity is being threatened.
You mentioned, we have to go, but you mentioned insects could overrun the Earth.
Well, that's in science fiction.
Yeah, but the cockroaches, they never seem to go away, Doctor. We got to figure out a way to get rid of them. All right, Dr. Michio Kaku, thank you so much. And your new book we're looking out for is Physics of the Future.
There's a giant asteroid flying towards Earth. Detected by a Russian robotic telescope, it's one of the largest and most dangerous space rocks approaching our planet's orbit. RT's Murad Gaziev looks at the threat from the void.
Humanity's last experience with a large asteroid was painful. Almost 2 years ago, the Chelyabinsk meteor, traveling at 19 kilometers a second, exploded in the skies above Russia. The blast was dozens of times more powerful than an atomic bomb. But that meteor was only 20 or so meters in diameter, weighing about as much as the Eiffel Tower. This new asteroid is an entirely different story. It's 20 times bigger, the size of a village weighing millions of times more. If this asteroid, for now called 2014 UR116, flew into our atmosphere, it wouldn't just burn up in the air and shatter windows. This would hit the planet's surface, potentially killing millions. But calm for now. It's not yet on a collision course with Earth. The danger is, as it passes near planets and the sun, gravity could alter its path. In fact, the Russian space agency, which detected UR116, has satellites watching just for such objects. And it's not only Russia. An American observatory a decade ago detected another similar asteroid. There was a big scare about that, if you remember. Apophis was named after the Egyptian god of evil, and asteroids that size hit Earth on average once in 80,000 years. NASA gave it a very real chance of impacting our planet, though that was later revised down. But the danger from asteroids is very real, and astronomers are increasingly keeping an eye out and thinking about what to do if they confirm a collision course, though don't expect anything quite as dramatic as Bruce Willis leading his team of misfits to save the world.
It's been almost 10 years since little Pluto was demoted from being a planet, but today scientists from the California Institute of Technology have announced that they finally have solid evidence for a planet X, a true ninth planet on the edge of our solar system.
It is believed to be far beyond the orbit of Pluto, roughly the size of Neptune, with a mass 10 times that of Earth.
There are things out there, little icy objects that are orbiting in a funny way, and nobody was quite sure why. It seemed like there might be something with gravity pulling on them, but nobody quite understood. And finally, these scientists that you talked about took a really hard look at it, did simulations, calculations, and they came up with the explanation: it probably is this giant planet.
I think I read somewhere it orbits the sun every 10,000 to 20,000 years.
Right.
Is that why no one has seen it to this point?
No, that's not why. It's because it's so dim. It's so far away that even though it's big, it's very, very dim, and it would be very tough to spot with a telescope.
I'm also fascinated at the idea that this planet could be so far out there and still our sun be the mass that is keeping it in the gravitational pull of our solar system.
Right, yeah, but no, it's true.
That's incredible. And so there was a thought at one point from scientists that when they thought that there was something beyond Pluto, that it might have been all the massive objects floating in the Kuiper Belt, but it's not.
Right, so all those objects are out there and they have a lot of mass, and originally the scientists said, look, a planet is such a crazy idea, maybe it's the Kuiper Belt itself that's pulling it on itself and making these orbits look funny.
And when we talk about the mass of this planet X, this ninth planet, being 10 times that of Earth, for those who are not scientists, what does that really mean, the mass of a planet versus Earth's mass?
Well, if you could put it on a scale, how much it would weigh.
Yeah.
I mean, that's really it. And so it's bigger, it's bulkier, it's got more heft, it's got more gravity. It's this huge elephant in the living room, except we didn't know it was there.
Mm-hmm.
You mentioned that scientists haven't seen it yet because of how far away it is and how dim it is. Is there a way for them to get visual evidence?
Yes, so the biggest telescopes in the world can theoretically see this thing if they're looking in exactly the right place. And with the publication of this new paper today, they are now going to start to look in earnest.
How much further out there is this planet X than the rest of the planets in the solar system? I mean,
so Pluto we think of as the really out at the very edge, the very farthest thing that you could call a planet, even though we don't anymore. And
I'm still supporting Pluto's right to be a planet.
But this thing is 5 times further out than Pluto.
Fascinating. Is there any chance it's not a planet?
No, there's always. It's very foolish to say no chance because you just don't know what you don't know. But the odds are looking very, very good.
60 billion miles from the sun.
Yep.
Amazing stuff. Michael Lemonick, thank you so much. Fascinating stuff.
Great, thanks.
Good afternoon. My name is Dwayne Brown with the Office of Communications, and welcome to NASA headquarters. Today, NASA reveals near-Earth asteroid findings and implications for future research from the agency's Near-Earth Object Wide Field Infrared Survey Explorer, in short, NEOWISE. Today's information and graphics can be obtained on the web at www.nasa.gov/wise. We will have brief presentations from our presenters, then open it up for questions at our NASA centers and the phone bridge. Before we get started, let me introduce you to today's speakers. First up, Lindley Johnson, NEO Program Executive, NASA Headquarters, Washington. Amy Meinzer, NEOWISE Principal Investigator, NASA's Jet Propulsion Laboratory, Pasadena, California. Tim Sparr, Director, Minor Planet Center, Smithsonian Astrophysical Observatory, Cambridge, Massachusetts. And Lucy McFadden, Scientist, NASA's Goddard Space Flight Center in Greenbelt, Maryland. And with that, I'll toss it to Lindley to start us off.
Thanks, Dwayne. Thank you all for tuning in to hear about our progress with the Near-Earth Object Observation Program. We're here today to provide an update of our understanding of the near-Earth asteroid population and announce achievement of some significant goals in finding our nearest neighbors in the solar system. Over the past 12 years, our work to find near-Earth asteroids has largely been done by several ground-based observatory teams. But in 2010, NASA augmented those efforts by enhancement of the ground processing of the data being returned by the Wide Field Infrared Survey Explorer.
So one of the characteristics of NEOWISE is that it really was a fairly small telescope in a low Earth orbit. In fact, the telescope would kind of fit under your arm like this, so it's not particularly large. But by virtue of being in space and operating at infrared wavelengths, it's a very powerful telescope, and it turns out to be very good at finding asteroids and comets. Now, if you go to the first animation here, you can see a little representation of what WISE looks like going around the Earth. It's always pointing outward from the Earth, surveying the whole sky. And as the Earth goes around the sun, this allows the telescope to very quickly and efficiently carry out a survey of the whole sky. And in fact, it was so fast we were able to survey the whole sky twice in infrared wavelengths in only 1 year. And you can see here a little representation of the difference between visible light and the infrared light that WISE was able to see. So this was a very efficient and effective way of surveying the sky. And the original purpose of the mission was actually to study cool stars in very distant galaxies, and it's doing a great job of that. However, it turns out to also be very good at detecting asteroids. This is because it's using infrared light.
First of all, I find it really exciting that scientists continue to find things in the solar system, bodies in orbit around the sun, and objects that are close to our backyard in the near-Earth space. I want to congratulate the team for your successes, and I know from experience that in order to conduct a survey and to locate and discover new bodies from spacecraft missions requires a lot of planning, a lot of ingenuity, huge amounts of computing power, and then hours and hours, months of discussions with colleagues and poring over the data to validate the results.
Thank you. I realize you're focusing on near-Earth asteroids today, but there's been so much talk about the potential for finding a planet X or some sort of large body through the WISE survey. Can you comment on any status on that sort of search, or maybe even reassure people that planet X isn't coming to get them next year?
Yes, this is Amy Meinzer. I'm happy to answer this one. Planet X is not coming to get us. But we are looking to see if there are any other bodies in the outer part of the solar system with the WISE data. This is a very natural project for WISE. And so we're still working on it right now. We've obviously just returned a huge amount of data from the telescope that's going to take us a long time to sort through. But the initial results are very promising. You may have seen earlier results where we've discovered a new class of very cool type of stars with WISE. But the search is still on, and we don't think that there's anything that's hazardous in the outer solar system. We think that this is just a sort of if there is something out there, it would be a large body in a roughly circular orbit.
Our next caller, Denise Chow from space.com. Denise.
So when you say the initial results are very promising, the initial results are very promising. Anything else you wanted to say on that point?
We've actually been able to confirm the discovery of 100 new objects that are these very cool stars called brown dwarfs. And so that's very similar to what people are interested in looking for. So we've actually found some of these that are relatively close to the Earth, but none of these are closer at this point than the nearest star to our solar system.